let's take a look at more examples on remainder theorem. Now, we have seen what remainder theorem is, and we have seen many examples of how do we solve questions on remainder theorem. So we know that if we have a polynomial px, and if we divide by a linear polynomial x minus a, so the remainder theorem says that the remainder will be nothing but the value of the polynomial at x equals a. Similarly, we have also seen that if we have a polynomial px, and if we divide it by a linear polynomial x plus a, then the remainder will be the value of the polynomial at x equals minus a. Now, we have also seen earlier that the more generic way of writing a linear polynomial is of the form ax plus b, where a, b are both constant and a not equal to 0. So what if we have our linear polynomial in this form? That is, here we talked about x minus a, here we talked about x plus a. But what if we are trying to divide a polynomial by a linear polynomial that looks like this? How can we then find out the remainder using the remainder theorem? So the question is, in this case, we want to find out the value of the polynomial at a certain value of variable, but what is the value of the variable? So one way to think about that is, if you go back to the first scenario, when x minus a is the denominator, we try to find out the value at x equals a, right? So we can think of it as x equals a. If you bring the a on the other side, we get x minus a equals 0. In other words, x minus a and x minus a. So if we equate our polynomial, the denominator polynomial, to 0 and find out the value of x, that is the value of the variable at which we are trying to find out value of the polynomial. Let's say if it holds true for the second scenario. So in second scenario, we have our polynomial as x plus a. So if we equate this to 0, we get x equals, we take the a on the other side, and we get x equals minus a. And indeed, we find the remainder by finding out value of polynomial at x equals minus a. So that means if we have it in this form, we will equate this to 0. So let's equate this to 0. Let's equate ax plus b equals 0 and find out x. So in this case, b will go on the other side. So we will have ax equals minus b. We divide both sides by a. So the a cancels out here, or x is simply minus b by a. That means if we find out the value of polynomial at minus b by a, that should give us the remainder when we divide px by ax plus b. Now let's take a look at some examples and verify this for ourselves, right? So let's say we have our polynomial. Let's write a polynomial px. Let's say our polynomial is 2x squared minus 5x minus 3. And we want to divide this by a polynomial gx, which is, let's say, 2x plus 1. So if you want to divide px by gx, what is the remainder? So what we will do is we'll first equate this to 0. So let's do that. So let's say 2x plus 1 equals 0. From here we get 2x equals minus 1, because the plus 1 will take it on the other side. And now we divide both sides by 2. So we will get x equals minus 1 by 2, right? Because this will cancel out. So if we were to find out the value of the polynomial, this polynomial at minus 1 by 2, now this should give us the remainder. So let's find this value. So we have 2x squared. So we have 2, x is minus 1 by 2. So 2x squared minus 5x. 5x, x is minus 1 by 2, minus 3, minus 3. So here minus 1 by 2 times minus 1 by 2 is 1 by 4. So we have 2 times 1 by 4. And here we have minus times minus will be plus. 5 ones are 5, so we'll have 5 by 2 minus 3. Now here these two will cancel out, so 2 1s are 2, 2 2s are 4, so we'll have 1 by 2 plus 5 by 2 minus 3. Now 1 by 2 plus 5 by 2 is simply 6 by 2 minus 3, and this is nothing but 3 minus 3, which is 0. So the remainder theorem is telling us that the remainder actually is 0. When we divide these two polynomials, we get a remainder 0. Now we wanted to double check this, right? So let's verify by actually doing the division, see what we get. So let's say, for example, we have now 2x squared minus 5x minus 3, and we want to divide this. We want to divide this by 2x plus 1. So what will be the first term? We are doing the long division. So 2x squared by 2x, that will give us x. So that will be 2x squared plus x. And now when we do when we subtract, so this cancel out. So minus 5x minus x is minus 6x. This 3 will come down, minus 3. Minus 6x by 2x. So if we have minus 6x, we divide that by 2x. So we get minus 3. So our next term is minus 3. When we multiply this, we get minus 6x. Minus 3 plus times plus 1 is minus 3. So when we subtract, so this becomes plus, this becomes plus. This cancels out, this cancels out. Indeed, we see our remainder is 0, just as the way the remainder theorem had predicted. Let's take a look at one more example. This time, let's say our polynomial px is maybe something like 3x squared plus 2x minus 5. So let's say our polynomial is this, and we want to divide this by the polynomial, let's say maybe 3x minus 5. So what will be our remainder now? Well, we will equate our divisor polynomial to 0 and find out the value of x. So let's say 3x minus 5, we are trying to divide like this, right? So we will find out this equals 0, or from here we will find out 3x equals 5, or we will say x equals 5 by 3, right? And now we know that the remainder of this division will be nothing but the value of the polynomial at x equals 5 by 3. So if we simply find this out, we will get our remainder. So let's find this value. So that we are doing it over here. So we have 3x squared. So we have 5 over 3 squared plus 2x, right? So it will be like this, minus 5. So this will be, so we will have 3 times 5 times 5 is 25 by 3 by 3, right? Because squared, plus we will have 10 over 3 minus 5. And here one of the 3 will cancel out. So we will have 25 by 3 plus 10 by 3 minus 5. So this will be simply, I think if we were to add, it will be 35 by 3. 35 by 3 minus 5, right? And if we do this, it will be 35 minus 15 by 3. 35 minus 15, I think it will be 20 by 3. So this should be our remainder when we do this division. So I'm not going to actually do this division right now. It will be a good homework, if you think of it this way, for you to actually go ahead and do the long division and see if you are indeed getting the remainder 20 over 3. Because if I were to do the division now, it will become a very long video. So I hope you are able to appreciate how we can use this remainder theorem, which is so powerful. And as long as our divisor polynomial or the denominator is a linear polynomial, we can apply remainder theorem to find out the remainder without doing the long division.